Today I want to talk to you about inverse functions. Inverse functions, we're going to say this several times in class, so let's go ahead and write it down first of all. To find an inverse function, switch x and y and solve for y. Sometimes you're not going to have to solve for y, but most of the time you're going to have to solve for y. So how do you find an inverse function? You switch x and y and then solve for y. Okay? Got 6 examples for you today. Here's example number 1. This is what's given to you. 1, 5, 2, 6, 3, negative 1, and negative 4, negative 2. That's what's given to you. And my instructions are to find the inverse. Well, how do you find the inverse of a function? You switch x and y. Okay? Well, if I'm switching x and y, instead of 1, 5, I'm going to have 5, 1. Instead of having 2, 6, I'm going to have 6, 2. I'm going to have negative 1, 3. I'm going to have negative 2, negative 4. I'm not changing the signs of numbers. I'm just changing the values for x and y. Just switch, 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 switch. Okay? Now, are they all going to be as easy as that? No. But is this one as easy as that? Yes. Okay? All right, example number 2. Y equals 2x plus 3. Now, I know I said switch x and y and solve for y. I also said you're not always going to have to solve for y. This is one of those cases. Example number 1 was one of those cases because all you had to do was switch x and y because all you were given was an x and a y. Okay? In a case like this, we got to switch x and y. And now we're going to have to solve for y because now there is a y to solve for. When I switch x and y, I get x equals 2y plus 3. So now I go about solving for y. So basically I'm trying to undo what's already there. How do I undo adding 3? Well, I subtract 3. And I do it to both sides so I keep the equation balanced. X minus 3 equals 2y. How do I undo 2y? Well, to undo 2y, I divide by 2. This simplifies to 1, so all that I have left is a y. This side I have x minus 3 over 2. Now I could rewrite this as 1/2 x minus 3 halves, but you already don't like fractions, so why would I want more fractions than just 1? Okay, this is a perfectly acceptable answer for the inverse of this problem right here. Okay, any questions on that? Example 3. Y equals x minus 4 squared minus 5. So how do I find an inverse function? I switch x and y and solve for y. So first thing I'm going to do is switch x and y. X equals y minus 4 squared minus 5. So I need to undo what's already being done so that I can get the y by itself. Undoing subtracting 5, inverse operation of subtraction is addition. So I add 5 to both sides. I get x plus 5 equals y minus 4 squared. How do I undo a squared? Well, I undo a squared by taking the square root. We've already done that, right? We've already done that this year. But here's the deal. If you know how to undo a squared, you know how to undo every other exponent. Because if I'm undoing a squared, I take the square root. If I'm undoing a cube, I take the cube root. If I undo the fourth power, I take the fourth root. Here's the deal, guys. The action that you take to undo something is the inverse operation of that, okay? Subtracting 5, the inverse operation is adding 5. The thing about this that's so interesting is that I have a function that's going on right here, a squared, and to undo that I take the square root. So what I now know is that the squared function, a quadratic, is the inverse of a square root. That's pretty cool. Okay. So a cube, the inverse function of a cube is a cube root. So on the left-hand side of this, I just get square root of x plus 5. On the right-hand side of this, I just get y minus 4. To solve for y, I add 4. The square root of x plus 5 plus 4 equals y. This 4 can't go inside the root, so it's got to stay outside. Okay? That is my inverse of that. Okay? Example number 4. Y equals 2/3 cube root of x minus 5. So how do I solve an inverse function? By switching x and y and solving for y. Okay? So switching x and y first gives me y equals 2/3 cube root of y minus 5. Adding 5 first gives me x plus 5 equals 2/3 cube root of y. Now, here is a talking point, okay? The 2/3 is multiplying by the cube root of y. Do we divide it since that's the inverse operation of multiplying? Well, we would, except for it's a fraction. And we don't divide by fractions because dividing by fractions gives us fractions and fractions. And like we said before, you already don't like fractions. Why would we want more of them? Okay? So what I need you to remember is that while we don't divide by fractions, we do multiply by their reciprocals. We're going to do that on both sides, multiplying both sides by their reciprocals. Well, what happens here? That's just 6 over 6. 6 over 6 is 1. That's why we choose the reciprocal. We flip it over, multiply it by that, because that gets us a value of 1. That means that's gone. Okay? So on the left-hand side, we have 3/2 times x plus 5. And on the right-hand side, we have cube root of y. How do we undo a cube root? Well, by cubing the whole entire side. By cubing this whole entire side. So y equals 3/2 parentheses x plus 5, all being cubed. This is the inverse of this. Okay? Example number 5. For example number 5, we have something different. I'm going to try to trick you with this one. So example 5 is f of x equals x squared plus 5 over 3. So how do we find an inverse? We switch x and y and solve for y. So the people that get tricked on this problem panic because there's no y. Except you know that in function notation, f of x is the same as y. So when I go to switch x and y, this was already y, so it is x. This was already x, so it is y. So hopefully you did not let yourself be tricked. Now I need to solve for y. How do I undo the 3? Well, the 3 is dividing, so I'm going to multiply both sides by 3. On the left-hand side, I have 3x. Right-hand side, that simplifies to 1. I just have y squared plus 5. I subtract 5 on both sides. So I have 3x minus 5 equals y squared. And how do I undo the squared? Well, that's the square root. So y equals square root of 3x minus 5. And now technically, what are we missing? We want to be technical when we can. I forgot on the other example, so I hope you forgive me for that. But anytime we take a square root, what should we be adding in front of it? A plus or minus. Okay? We should be adding the plus or minus. This is the inverse of this. Now the difference for here is that we're not done. Okay? If this was given to us in function notation, we need to write our answer in function notation. Okay? Now here's what's interesting. Function notation is this. Now, does this look like an exponent? It does, right? It is not. It is a notation that says that this is the function we started with. This is the inverse of that function. So sometimes on your homework or a test question or a quiz question, it's not going to say find the inverse. It's going to say find f negative 1 of x, except these two things mean the same thing. If it says find f negative 1 of x, it wants you to switch x and y and solve for y. It wants you to find the inverse. Okay? Last but not least, example 6. So I'm giving you a graph, and I want the inverse. There's two ways to do this problem. The easy way and the other way, in my opinion. Okay? In my opinion, the easy way is to find some points on this graph. Maybe this point is like negative 5, 0. Maybe this point is 0, 3. Maybe this point is 2, 0. So now the inverse of this would be 0, 2. The inverse of this would be 3, 0. And the inverse, let's see, 0, 2, 3, 0. And the inverse of this would be 0, negative 5. So down here, because remember, just like the first example we did, if we have some points, all we have to do is switch x and y, just like that. Only difference is we had to find these. We go plot them again. Let's see if I can do this like that. Now here's the thing about inverse functions. To find an inverse function, we switch x and y and solve for y, right? So in a way, we're kind of making x and y equal to each other. Well, if x and y are equal to each other, it seems logical that I could plot this line on this graph. And if I did, what I hope you'll see is that the graph and its inverses actually reflect across the line y equals x. If I folded this paper right here, right on top, right on that line y equals x, you would see that these are on top of each other. Those are on top. These are on top. They would be right on top of each other. That's the other way. It's not, in my opinion, as easy as finding points that are given on the given graph, reflecting, as finding the inverse, so switching x and y and plotting the new points and connecting them. But that is how you find an inverse. So one more time, how do you find the inverse of a function? Switch x and y and solve for y. So I have a worksheet for you today. Would you please circle the following numbers? 1, 3, 6, 8, 10, 11 and 13, 16 and 17, 20, 21, and 24, 25, 27, and 28. Okay? Peace.